Hi. In this video, the three-phase 9-level inverter-fed induction motor drive is simulated using MATLAB. First, the single-phase 9-level inverter topology is built with SimScape and specialized power system components. Two universal H-bridge modules are taken and configured as single-phase MOSFET H-bridge inverter. Both are connected and gating pulses are combined through the multiplexer to construct a single-phase 9-level cascaded H-bridge multi-level inverter. Both H-bridges are grouped and subsystems are created to build a three-phase circuit. Gating pulses are produced using MATLAB functions. In MATLAB functions, the switching states of 8 switches are described for the sinusoidal reference input. A 50 Hz, 1 volt sinusoidal reference is used to produce the switching pulses through the MATLAB functions. 1 volt is scaled to 9 levels, that is 4 levels on positive and 4 levels on negative. Including the 0th level, switching pulses are generated for 9 levels, so 1 volt represents 4 levels on the positive side. By reducing this magnitude, less number of output voltage levels can be produced. In the basic H-bridge circuit, the positive voltage of the input is achieved by turning on one pair of switches, and the negative voltage of the input is achieved by turning on the opposite switch pair. The 0th level is used to provide the conducting path to provide different levels with the combination of another H-bridge. The switching states are defined for the period of 0 to 90 degrees and from the 0th level to the 4th level, which is the first half of the sinusoidal reference. The remaining period from 90 degrees to 180 degrees is repeated utilizing comparison. To produce the negative half, the switch pairs are swapped. The symmetrical nature of the cascaded H-bridge produces the same 4 levels in the negative polarity. A resistive load is used to see the output voltage waveform. To produce a 230 volt AC output, 325 volt DC input is required. This 325-volt DC input is split into two with the ratio 1:3. So 1 VDC is taken as 1/4 of the maximum voltage, and 3 VDC is taken as 3/4 of the maximum voltage. As a result, a 9-level output obtained at 230 volts, 50 Hz. Simulation parameters are set for the simulation. Stop time is set as 0.1 seconds to observe 5 cycles. ODE23TB is used as a solver, and 5 microseconds is used as the maximum step size to run the simulation. Due to the wrong entry of the 3VDC, the 9-level output is not obtained. It is corrected and a 9-level output is obtained. THD value for the 9-level output can be measured using the option available in MATLAB. To measure the RMS value, the RMS block is used with the setup of fundamental frequency 50 Hz. After verifying the working condition of the single-phase 9-level inverter circuit, it is changed to a 3-phase 9-level multi-level inverter circuit by duplicating the single-phase circuit. To produce a 3-phase voltage, the sinusoidal reference input of each phase is displaced by 120 degrees. The simulation is run to see the phase and line voltage of the inverter circuit. The output voltage is analyzed for the different magnitudes of the sinusoidal voltage reference signals. .4 H 400 volt 1430 RPM squirrel cage induction motor used in simulation. The magnitude and frequency of the sinusoidal reference input are reduced to half to implement the V-var F speed control technique to run the machine at half of the rated speed, and the corresponding waveforms are analyzed. The values of the sinusoidal reference can be varied between its minimum and maximum range, and the performance can be measured. Thanks for watching the video, and use the link to download the Simulink file. Subscribe to the channel for more similar videos.